Alright, so first video with the new platform. Alright, this is your twin for the test/quiz you have next Thursday. Gonna take a little longer to do these, but it should look better. Maybe you'll like it better. So let's start with the first question, just a classic trig problem. Given the sine of an angle is 5/9, find the tangent of that angle. Now, it's going to be a little different for me on orientation because I'm not writing on a screen, I'm writing on a piece of glass and trying to line up. So we're going to think about what the sine ratio is, and the sine ratio, classic trig from good old SOHCAHTOA, is opposite over hypotenuse. So if I put theta in the corner, opposite of theta is going to have to be a 5. And the hypotenuse is going to have to be a 9. Now you're going to use one of the oldest theorems that we have as a people to figure out the missing length. So we're going to do some a squared plus ab squared equal to a c squared. Now I don't know this side. My b's have a tendency to look like 6's, so I always call the missing side a. A squared plus 5 squared is 81. You know, I just noticed you can't even see me. Let's turn on some teacher light there. There I am. Alright, so I guess I should have said 9 squared for some of y'all's math ability there. Anyways, we got a 25 here, we have an 81 there, we have the a squared. We're going to subtract the 25 from 81, and what's that going to give us? 56? Seems right. A squared is 56, and we're going to counteract squaring by square rooting, so a is the root of 56. Now 56 would be 2 times 28 or 4 times 14. So I can think of this as the root of 4 times the root of 14, which is 2 roots of 14. Big deal. Always simplify radicals. This is 2 root 14. Now again, the goal here was to find the tangent ratio. See where it says find the tangent of the angle? Find that guy right there. Missed it a little bit, didn't I? Still missed it. Third try. Find the tangent of theta. The tangent of any angle from SOHCAHTOA is opposite over adjacent. So opposite of my angle is 5. This is the opposite side. Adjacent is 2 root 14. So we're going to get 5 over 2 root 14. Now we're going to clean this up because somebody a long time ago said no radicals in the denominator. So we're going to clean this up by multiplying the numerator and denominator by the problem, and the problem is root 14. Down low, when you do this together, you get a 14. You already had a 2, so it's 2 times 14. Up top, it's just 5 roots of 14. We just kind of merge them with glue. And then 2 times 14 is going to be 28. So we're looking at 5 roots of 14 over 28. And there's that one. All right, moving on to the second one, and there's lots of ways of doing this one. I actually like the circular approach for the second one. We're supposed to find the tangent of theta using a circular approach. And the tangent of theta using circles is y over x. Or sine of x over cosine of x, or theta, whatever we want to use here. Lots of ways of doing it. But this is the quickest way to do it, and obviously I'll go back and I'll do it with a triangle. But if I'm sine over cosine, I would just simply be 5 roots. Wrote that wrong, didn't I? I would simply be a root of 5 divided by 2, sitting over a root of 2 divided by 2. Now, the things that are in corresponding places will cancel out. So that's gone and that's gone. And I've got root 5 over root 2. We clean this up a lot like I did the one up here. I'm just going to multiply the numerator and denominator. You have to forgive me, I'm a little bit sick, by the root of 2. Now root of 5 times root of 2 is going to be root 10. It doesn't simplify, and a root of 2 times root of 2, and I say this all the time in class, if you multiply a square root by itself, you get the number inside, 2. Final answer is going to be root 10 over 2. Now, if that seems a little too foreign to you, and you're like, but it's trig, I got to draw a triangle, then you just draw the stinking triangle. The triangle is going to look like this. We always put our angle in the corner. The angle is called theta. And we're going to have to follow kind of our ratios here. We have sine, which is adjacent over hypotenuse. So next to the angle is going to, sorry, sine is opposite. Opposite of the angle is a root 5, and the hypotenuse is a 2. Cosine is given as root 2 over 2, and cosine is adjacent over hypotenuse. So here's my adjacent length, root 2. Now I'm doing tangent. I've done TOA earlier just a few minutes ago. So the tangent of the angle would be opposite over adjacent, which is going to be root 5 over root 2. And you'll see that it lines up with what I was doing over here. So pick your pill on that one, okay? I don't know which one you want to do, just pick it and go with it. And we'll move on to the next one. Here's the one thing about this board, you actually have to erase it. So these are going to take longer. The setup's actually a little bit longer too. These videos are going to take longer, but I guess that's okay. If it leads to more student learning, so be it. A lot of money was spent on this for y'all. Good chunk was. All right. Now, number 3 is meant to be done entirely from a circular perspective. Entirely from a circular perspective. It doesn't have to be, but the quickest way to do it is to use a circle. Now, you'll notice that I want the secant ratio. That's what the text says, secant ratio. Secant ratio on a circle is simply r over x. That's all secant is. Nothing more. So your x-coordinate's right here, and the radius is right here. And we're just going to do r over x. The secant of the angle is going to be 6 over root 11. Now all you have to do is clean that up just a little bit. Multiply the numerator and denominator by the square root of 11, and you'll be done. 6 times root of 11 is 6 roots of 11, and a root of 11 times root of 11 is 11. So there you go, 6 square roots of 11 sitting over 11. Fourth one, alpha being drawn in standard position intersects the unit circle. Now do notice that it says unit circle. Because it says unit circle, the radius is 1. Evaluate the sine of alpha, the cosine of alpha, and the tangent of alpha. This is the easiest problem on the whole test. On the unit circle, the sine of an angle is y. The cosine of an angle is x. And the tangent of an angle is y over x. So when I talk about the sine of theta, all I have to know is the difference between x and y. And if you're a 17-year-old and you still haven't figured out which one's x and which one's y, you have not been trying now, have you? The y-coordinate is root 7 over 4. And there is supposed to be a negative symbol there. It's kind of hard to see, but it's negative root 7 over 4. The cosine is going to be the x-coordinate. So the cosine of this angle is going to be negative 3/4. Now the tangent one you're going to have to work on. The tangent of the angle is y over x. So it's negative root 7 over 4 all over negative 3 over 4. And that's not so bad. It's really not. The negative symbols are going to cancel out. The 4s are going to cancel out. And you're just going to be left with root 7 over 3. Kind of got into the next question there, but there you go. Pause, do whatever you need to do, but be thinking. Trig is really, really easy, but there's always a lot of little things about trig. All right, moving on. Got a classic problem from geometry level question. Standing on a building 300 foot tall, you look down at a car. So you're on a building, and I'm just going to draw a vertical side of a right triangle. And it is 300 feet up. Okay? You're looking down at a car. I'm just going to put the car over here. There's a car over here. It says if the angle of depression to the car is 61 degrees. Now, a lot of kids put these in the wrong spot. It's not where you think it is. It's really not. The 61 degree angle lies here. Now, if you go back to 8th grade math, you learn about parallel lines, you learn about something called alternate interior angles. The angle of depression is equivalent to the angle of elevation. I want to know how far the car is to the building, which presumably formed a right angle with the ground, or it wouldn't be much of a building now, would it? So we'll just call that x, and then we'll do some classic trig. You know, what is 300's relationship to the angle? Well, 300 feet is opposite of the angle, and x is adjacent to the angle. So I'm cycling through SOHCAHTOA, which, you know, this gets worse every stinking year. Every year it gets worse. The spelling, so, S-O-H, CAH, C-A-H, TOA, T-O-A. I think it didn't show up too hot, did it? All right, so I notice I have the O and the A I am tangent. Now, the argument or input of the tangent function is an angle, and that angle measures 61 degrees. And it must equal 300 over x, opposite over adjacent. We're going to cross multiply to some degree, or x both sides. And we would have x tangents of 61 degrees being equal to 300. Now, to isolate the x, we're going to have to do a little bit of division. We're going to divide both sides by the tangent of 61 degrees. Now, the one thing that this new board doesn't let me do is it doesn't let me really pull up a TI-84, so you can see that. But I'm going to go push buttons on a calculator here. Make sure that you are in degree mode, obviously. You can see I got a calculator. That's what I got. So I'm doing 300, sitting pretty over the tangent of 61. And if you're at home, you know, play with this. It's a screen record, so even if I pull up a calculator over here, you wouldn't see it. But it's about 166.29 foot. There you go. All right, moving on to number 7. 7 says a sprinkler rotates through an angle of 150 degrees, spraying water 35 foot. Determine the area being watered. So the reason that test takers draw is because, believe it or not, the visualization of the diagram helps you recall the formulas and things you're supposed to do. And there's lots of ways of teaching these particular types of problems. But the way I taught it this year in Algebra 2 was to use a formula. And that is a sector. It's a very large slice of pizza. And we rotate 150 degrees, so we have a 150 degree central angle. The radius of the full circle, if there was one, would be 35 foot. And you guys were taught the formula that the area of a sector is 1/2 r squared theta, with the disclaimer that this is a radian. All right? So I have to convert 150 degrees into a pi rad. And if I've forgotten that, then I'm going to have to do 150 times pi over 180, right? Which zeros, degrees, symbols cancel. 15 and 18 both divisible by 3. And I get 5 pi over 6, which is exactly what it is on the unit circles that I asked you to memorize. So there we go. There's my angle of interest. All right, going over here, we have 1/2. We have 5 pi over 6 for the angle of interest. Or sorry, I did that out of order, didn't I? I apologize. The radius is 35. We're going to have to square that. And the angle of interest is 5 pi over 6. So let's see what that comes out to be. If we take a 35 and we square it, we get 1225 multiplied by 5 divided by 12. In pretty form answer, I get 6125, don't forget about pi, over 12 square foot. Again, you probably shouldn't tell the average person that answer because they're just going to be mad at you because they're not going to understand it. And the truth is they're going to be like, they won't really comprehend this either. It's about, if we round, 1,603.5 square foot, which a lot of people say, man, that's a lot. That's nothing. That's a rectangle that's what? 160 foot by 10? It's not that big. It's not that big. All right, we're ready to move on to a different page. Now, these videos are going to take me longer. I'm noticing that quite a bit, but hopefully they're better, right? Hopefully they're better. I'm sure I'll probably need to spend some time editing this, but I just don't have that kind of time because nobody wants to spend time watching me erase a piece of paper. All right, moving on. If a sector has a central angle of 12 pi over 7 and a radius of 13 inches, what is the sector's arc length? Now, I'm not going to draw this one because it mentioned arc length, and at least in my Algebra 2 class, we call arc length S, and it has the formula SRT, or S equals R theta. And they have given me everything I need to find S. S is the unknown, the radius is 13, and the angle of interest is 12 pi over 7. Now it says leave your answer in exact form. I'm going to penalize decimals. It's not going to be that hard. Excuse me. You're just going to have to figure out what 13 times 12 is and divide it by 7. So that's what I'm doing. I'm doing 13 times 12, it's 156, and dividing it by 7, and I'm converting the fraction, and it's 156 over 7. Don't forget pi. And that would be in inches, because it is a concept of length, not inches squared, inches. All right, number 9, evaluate the cotangent of negative 3 pi over 2. Now, I'll show you two different ways of doing this. You may not like it, but I'll show you 3 different ways of doing this. First off, for a lot of people, they have to work in degrees. So they're going to take their negative 3 pi over 2, and they're going to convert it into degrees. Now that's going to give me negative 270 degrees. Ah, well, there is no actual way to do this with triangles now, is there? But let's think about this, and we're going to use the concepts of the unit circle. So here's my circle. I am rotating negative 270 degrees, and I get right here. That is negative 270 degrees. Now, my coordinates here are 0, 1. So this is definitely a circular concept question if you're doing it by hand. On the unit circle, the cotangent of an angle is x over y. My x-coordinate here is 0. My y-coordinate is 1. My answer is 0. I thought I'd show you 2 different ways, but I didn't actually read the question. Number 10, find 2 angles coterminal with 142 degrees. Coterminality means that we just plus or minus 360 degrees as many times as we need. Be prepared for this to be multiple select. Be prepared that you might have to add 360 more than once or twice. You know, if I do 142 and I add 360, I'll have 502 degrees. And I could add 360 again. I don't need to stop until I see what I'm looking for. And if I did that, I think I would have 862 degrees. Now, in addition to adding, I can also do subtraction. So I could do 142 minus 360, which is a lot harder to do, actually. It's negative 218, I believe. And if I can do it once, I can just keep doing it over and over and over. So that'd be negative 578 degrees. And again, your job on a question like this, since it's probably multiple select, is to just keep adding and subtracting until, right? Until you find a desired outcome. A lot of kids, they just want to do something once or twice and be done, but, you know, that's just kind of stupid. You do things until they're finished. Not until you're finished, until the task is finished. And again, that will probably be multiple select, so you might have to add or subtract a few times. All right, which two angles are coterminal with 13 pi over 6? And it's kind of the same concept, except we're going to be doing here is we're going to be doing add or subtract twice pi. Now, I don't know why, but I feel like doing this the old school classic way, which is by hand. So I'm seeing a pi over 6, and 2 pi would be 12 pi over 6. Hopefully you understand that. So I got a 13 pi over 6. If I add 12 pi over 6, I would get 25 pi over 6. That might be an answer. I could continue to add 12 pi over 6, and I would get 37 pi over 6. That might be an answer, okay? I could do it again. I don't know. I haven't completely finalized this test. And I'd get 49 pi over 6. And in addition to doing the addition, I could turn around and I could do the subtraction. So if I took away 12 pi over 6, sorry, that kind of bled into the next question, didn't it? There we go. If I took away 12 pi over 6, well, I'd have 13 minus 12, which is 1 pi over 6. And I could just keep doing that over and over and over, and it will be multiple select. Your job is to find those correct choices, okay? That is your job. Find the correct choices. All right. Next one. Using reference angles in a 30, 60, 90 pattern, evaluate the cosecant of 11 pi over 3. And this is worth showing more than one way. You don't have to use reference angles. You can also use circular concepts, okay? Does everybody that I'm teaching this year know the unit circle? No. Will everybody know the unit circle next year? No, because some kids, you know, you're hard-headed and you're not going to learn. You see everything that we teach you as just kind of like, I'm not going to use this, and you may not. I can't guarantee you that. But I do think, and this comes from years and years of experience, personally, that if you just throw away everything, you'll be less of a person. So try and make some sense of this stuff for your own sake, if not for your sake, for your children's sake. So I'm doing the cosecant of 11 pi over 3. Now, 11 pi over 3 is something that I want to make smaller. So what I'm going to do is I'm going to keep taking away 2 pi. I'm going to take away 6 pi over 3. And that's going to give me 5 pi over 3. Now, I have asked you guys to memorize certain things. 5 pi over 3 is 300 degrees. And you have been asked to memorize that, and most of you have memorized that. So let's draw a 300-degree angle. All angles start again on the positive x-axis, and then they rotate to a terminal side. That would be roughly 300 degrees of positive rotation. The reference angle, which is what it takes to get to the closest x-axis, is 60 degrees. Now, I've also asked you to memorize some 30, 60, 90 patterns. You've got a 30-degree angle, and opposite of 30-degree angle is a 1. You've got a 60-degree angle, and opposite of that is a root 3. And you have a hypotenuse of 2. So we're going to triangle that thing out. And opposite of 60 is a root 3, but direction is extremely important, so it's negative. Adjacent to 60 is a 1. It's moving right, it's positive. And the hypotenuses are always positive. Now you want the cosecant ratio, and even though this is on YouTube, cosecant's a hoe. Plain and simple. The cosecant ratio is hypotenuse over opposite. It is your favorite ratio because of what it is. Now the hypotenuse is 2, and the opposite length is negative root 3. And that pink just don't show up as well, does it? Now we're going to multiply the numerator and denominator by a root of 3. We're going to automatically move the negative symbol up top. Negative 2 root 3 sitting pretty over 3. Was that the only way to do this question? No, it was not. As soon as I saw 5 pi over 3, I could have taken a circular approach to this thing. And this is going to be just for reference only. You guys have memorized the unit circle. You're at 300 degrees. The ordered pair here is 1/2, comma, negative root 3 over 2. That's what she is, right? And on the unit circle, the cosecant ratio is 1 over y. It's actually r over y, but if you're on the unit circle, it's 1 over y. So it's going to be 1 over that funny looking radical. And I know for some kids that's kind of hard to comprehend, but it's 1 over this. Now, when you divide 1 by any fraction, all you have to do is reciprocate the fraction. It's going to be negative 2 over root 3. And then you clean up just like I just did. You multiply the numerator and the denominator by a root of 3. And you get the same exact answer that I got with triangles. Again, you pick your pill. Are you red pill, blue pill? Nobody cares, but you pick one. I got enough time to do one more question, which is about half this twin, which I'm pretty happy with because this is my first day using the board. It'll get faster and faster as I do more of these. Using reference angles in the 45, 45, 90 pattern, evaluate the tangent of 19 pi over 4. All right, so 19 pi over 4, what we're going to do, I'm just going to do it up here because I have more room, is we're going to take away 8 pi over 4, which is going to be 11 pi, because 19 minus 8 is 11. And then we're going to take away 8 pi over 4 again. And what are we going to get here? 11 minus 4 is 3. 3 pi over 4. Now 3 pi over 4 you've memorized to be 135 degrees. This is the tangent ratio. I can tell you right now that the answer is going to be negative 1. But anyways, let's draw a 135 degree angle. We'll start on the positive x-axis. We'll rotate 90 and then 45 more. The reference angle measures 45 degrees, and that is a reference angle. The 45, 45, 90 that I asked, one of the 3 patterns I asked you to memorize went 1, 1. Legs are the same, root 2. So we do a triangle out. Size and direction do matter, contrary to what you may or may not have heard. We go back 1, we go up 1. Root 2. You are tasked with doing the tangent ratio on this one. Tangent is opposite over adjacent. So opposite is going to be a 1, adjacent's a negative 1. And we get negative 1, just like I told you a few seconds ago it would be. Now, I don't care on your test if you do a circular approach. I really, really don't. Because that means you comprehend the circle. So you got to 135 degrees. You saw the ordered pair, which was negative root 2 over 2, positive root 2 over 2. And you thought about all the things Milbrath asked you to memorize. And one of them was that the tangent of an angle is y over x. So you get root 2 over 2 divided by negative root 2 over 2. And that is something divided by itself, which is 1, and it had a negative symbol, so it's negative 1. All right, kids, there you go. I hope you like the new board. I'm going to get a backdrop. That'll clean it up quite a bit. Eventually I'll learn not to stare at the laptop so much because it'll be in front, not behind. But I haven't got a wireless keyboard and mouse yet.